Hello, everybody. Thank you so much for joining us today. We're going to be talking about 3 tips for cross-curricular coding. This session is recorded, but we're going to be joining live from the chat. So if at any point you have any questions or you want to pop in and say hello, introduce yourself, tell us where you're from, please write us in the chats. So my name's Lauren. I'm from the Unruly Spots team. Excited to be here today. We are an ed tech company that focuses on combining coding with physically active play. And I'm joined by Dr. Cory Gleasman. Cory, did you want to introduce yourself?
Yeah, hi, I'm Cory Gleasman. I'm an assistant professor of computer science education at Tennessee Tech University. We actually have the first computer science ed program in the state of Tennessee, and it started last year. We have our first cohort graduating this summer, and I'm really excited to be here to talk about how you can cross-cut coding in your already pre-made and formatted curriculums that you're teaching now.
Awesome. And Cory, you have a undergraduate program and graduate program. So you're working with mostly the elementary and middle school students, right?
Yeah, I'm actually working with all K through 12 teachers. And so I work with both pre-service and in-service teachers, so at a graduate and undergraduate level.
Awesome. All right, so coding is the topic of the day. Before we get started on the tips, wanted to kind of get a holistic picture of what is coding? What does that mean?
Yeah, so a lot of the time I actually come across the everyday person and they don't believe they can ever code. And teachers, they're starting to change their mind too as well. A lot of them may say, I don't think I can integrate this into my classroom, but using some tips that we're going to share with you today, you will start to see that coding is practical and it's not as complex as you'd think. If you look at some of the code in that picture on the right, it looks fairly complex. However, coding concepts at their core are fairly simple, and it's just more about thinking. Coding and computer science are different. Computer science is about a holistic way of thinking and interacting with devices and technology, while coding is a part of computer science. It's really a skill within the computer science, and it's almost like learning a language.
Awesome. And so part of that is block-based coding. This is sort of how I learned decoding. So how does that relate to computer science and coding in general?
Yeah, so the block-based programming languages, they share all of the same foundational concepts as any text-based programming. However, they're more intuitive and they have a functionality which makes them much more accessible to all learners. And so you can see on the right-hand side, instead of having text that's strung together, you have code that's strung together in a specific sequence, which produces a solution and maybe tells the computer or a product or a technology that we're using a specific set of instructions.
And this is amazing because it means that we can now introduce coding to students as young as kindergarten, where, as long as they can read, then they're able to create the instructions for the code in a drag and drop, super simplified way. So it's just a really great way, I think, to introduce coding concepts to kids.
Yeah, you're right. And it's a way that they can learn those foundational concepts early and then carry them on with them throughout their years in education and then even further.
Absolutely. All right, so let's head into our 3 tips for cross-curricular coding. We'll dive into the first one here. So scaffolding your lessons to be flexible. Now, how does this apply for virtual and hybrid now that we're living in this world?
Yeah, so the way that you can introduce coding virtually or in maybe a hybrid or flipped classroom setting is utilizing the technology to help you. Unruly Spots, they have an online platform which allows you to code on that platform. It also allows you to use, you don't actually have to have the tangible technology in all settings. You can code a virtual splat to work. So you can still talk about coding, introduce it to your students virtually, and you don't necessarily need that tangible technology with you. And that's one thing I love about the Splats platform. But you also, when you're being flexible in and outside of the classroom, even if you're teaching online, you want to cater your instruction to the different needs of your students. And we'll talk about differentiation. That's kind of one of the main part of this tip. But the goal here is to use technology as something for learning instead of something more required of us as teachers. And we don't want to require more from our students either, but we do want to teach these computer science foundational concepts. So there's ways to do this, which are practical and make it easier on us. And we're going to go through them today.
Awesome. And I love that you talk about that. We don't want technology or coding to be something additional for not just our students, but our teachers to have to think about and to think, oh, now I have another thing that I have to do. That's not what we want. We want it to be something that's easily incorporated into existing curriculum. And even aside from SPLATs, which we'll talk about later, just in general, I think this tip really applies to any sort of technology that you're using
Yes.
in your classroom. Awesome. So do you mind walking through sort of tips? What does differentiation mean, and sort of walking through these tips that you've put together?
Yeah, so when we differentiate instruction for our students, it really means that we can take one activity and display it or guide our students in different ways based on their ability level or maybe their prior knowledge that they already have, or maybe you want to use a similar activity at different grade levels. And so ways that we can do this is by limiting the number of blocks used. We can place requirements on a piece of code. We can create a challenge for them. We could also incorporate it into a story problem if you think of math, where students are able to actually apply concepts to a story problem. You can do the same thing in coding. We also can provide our students with faulty code. This is called debugging, and we'll look at an example of this, but you can give them a solution that isn't necessarily correct, but you as the teacher know where those kind of errors are in the code, and you can guide them. You want to give your students in any of these tips that we have here free range to kind of go down different solution pathways, I call them, but you want to know as the teacher what those solution pathways are so that you can really highlight the learning opportunities when they arise. And you just want to be practical. That's one thing that, and Lauren just mentioned, we want to use something that is beneficial to us and makes our job easier as educators. And so these tips are practical and will help you integrate it into your curriculum.
Great. I think we're going to dive into a few tangible examples of what this looks like too. So, but before we do, it does have to do with unruly spots. So we'll just kind of explain what they are, the elusive unruly spot that we've been talking about. So Cory, can you kind of describe what unruly spots are? And then I'll show a video of what they look like.
Yeah, so unruly splats, they really encourage engagement and active play. They're tiles, which you can code. So you give those tiles instructions, and then you as a learner can go actively either tap on those tiles or they have preset instructions on them. But on the back end is all of this coding we're talking about. So we code just as if you were to code a computer, we are coding tiles. And you'll actually see a video here. And then what our job is as a teacher is these are engaging tools anyway, but how can we promote learning of specific concepts? And so we'll talk about that, and I'll share some of the activities that I use with my pre-service and in-service teachers.
Great. So this is an example of Four Corners, which was a student coded game. And so that's what this is really all about, is students are coding their own active games and coding the rules to the spot. So I'm just going to show a quick video of what that looks like. This is a class in Ohio.
Oh, all right, go back. Again. Should we do it again for you guys?
Yeah. Do it for
You ready?
more times.
Okay, get ready.
Go.
Three.
5, 4, 3, 2, 1.
Which one went off?
5 jumping jacks.
All right, and that's just an example of sort of what the slots do. So you can see in the Four Corners example, they all light up a different color and the students have to pick a corner, and the one that goes out means you have to do 5 jumping jacks. And so, it's really flexible because the students can actually pick, what happens when the spot goes off.
Yeah, and some of the learning here happens with the instructions that are applied to those splat tiles. So those coding instructions that your students can code. And create this game themselves. And so one that I do that is different than that example, but it's a pedometer challenge. So it counts your steps, and I'll have my teachers think about how they could integrate this activity. Sometimes I'm working with kindergarten, first, second grade teachers, and they want to limit the number of blocks to 4 blocks. You can create a pedometer, and you can differentiate your instruction to actually create a pedometer using just 4 blocks. So on this slide, you can see the 4 blocks which you can use to create a very simple pedometer. But then if we go to the next slide, you can see how I'll have some high school teachers actually differentiate this instruction. So I practice what I preach. I give this to my in-service and pre-service teachers, and I ask them to complete this challenge. And so this is one of our tips. I limit the scope of the blocks that they can use, and then I also give them a challenge of creating a pedometer and possibly running for 10 seconds or giving them different requirements of that challenge. And so I say you can create a pedometer using these blocks, but I want them to create rainbow colors this time. And so if we go to the next slide, we can actually see the solution. And so this is a solution that one of my teachers made. There's a few different solutions that can be made with the blocks that I provided. However, I have that teaching knowledge, I call. I know prior to this activity, sometimes I learn on the fly, and there's an innovative way that a student comes up with that says, hey, I made a pedometer. I'm like, oh, that's a new way to do it, which is great. But I know some of the avenues, the solution pathways, and I'm able to leverage them as teaching opportunities. And we'll talk about, I'll give you an example. There's a lot of different math concepts in here. There's a lot of, obviously, computer science concepts that can be elicited from just this code. So you can teach other content, not just the programming. And we'll talk a little bit about how to do that.
Yeah, and this applies even beyond Splat technology. You know, if you don't have Splats, that's okay. But this sort of flexible learning and is definitely relevant and helpful, even if you're using other coding technologies. So we'll give you an example of what this looks like, the pedometer. So pedometer is really just a step counter. So here's some students from a school using the Splats for that. So it's just a quick video. And I love this one because it is competitive, and kids naturally love competition. And so I know some people have opinions that, you know, competition is not necessarily a good thing for students, but you know, I've seen a lot of kids do this pedometer challenge, and they're so excited. They're like, let's do it again. I want to beat you the next time if they didn't win the first time. And so it is a great way to kind of get that teamwork. You can see the students kind of tapping each other in. So this is a really fun one. It's one of my favorites of all of our games that we have.
You'd be amazed at you'd be amazed about how motivated and competitive teachers get as well when they're creating these. You'd be surprised. It's not just students.
Absolutely, it's fun competition, friendly competition.
Yeah, exactly.
Awesome, and that brings us to our tip number 2, which is promoting complex connections. So what do we mean when we say a complex connection?
Yeah, so what we mean, a complex connection, what it is and what we mean when we say complex connection is that there's an interaction between, we're calling them computational thinking concepts, which are like the concepts that are in coding, and how they interact with core content concepts that we're teaching. That may be social studies, math, all of the sciences, even English. And how they create conceptual teaching opportunities. So how those two interactions create a conceptual teaching opportunity is what we want. When the core concept and the computational thinking concept that's in coding, when they abstractly drive the learning is what we want. We don't want to just promote memorization. When you're teaching coding or any rote skill, it's easy just to promote memorization, and then they can't apply that to other settings. However, we are looking at a way that we can promote that abstract interaction between those two concepts. And we want to enable constructionism. So that aligns with our complex connection. And constructionism is really about, it's really about enabling the learner to construct their own knowledge. So we don't want to passively just give them the knowledge, but we want to allow them to construct their own knowledge. And that's what I think these coding platforms truly do, because they are constructing games, and there's different ways to do that. We're not giving them step-by-step tutorials necessarily.
Absolutely. That sort of student-led learning mindset of letting the student be the driver of their learning and to be the creators.
Yes. Yeah. And so the way, this is kind of how I rationalize it or visualize it in my head when I'm creating activities, and when I have my teachers, my in-service and pre-service teachers create their activities for their classroom. They'll think about that standard, that content that they're teaching, any K through 12 content. They'll think about a block-based programming activity possibly that they want to teach. And then they think about the computational thinking concepts that are inherent in the programming language. Sometimes this computational thinking concept could be an idea like decomposition, or it could be an idea of sequencing, or the idea of looping. A common one is one called conditionals, which is like an if-then statement. If something happens, then it triggers something else to happen. And so here's an example of a computational thinking concept of a conditional. One of my teachers created a place value house that they wanted their students to code. And within this place value house, if you have looked at place values, I know some of us, it's been a long time since we've actually tried to investigate place values, but once the nine's value reaches a value, the one's value reaches a value greater than 9, you will add 1 to your tens place value. And once your tens place value reaches a value greater than 9, you would also then add 1 to your hundreds place value. And so this is really a conditional statement, and this is the connection that the teacher made, that if the place value is greater than 9, then it will move to the left, it will increase by 1. And so they really made a complex connection between place value and the programming language and the activity, and they used the idea of conditionals, or a logic statement, which is a computational thinking concept, to tie the two together. And so this is what we want to aim for, because it really makes our job easier.
And this is using a tool called Scratch, is that right?
Yes, it is. And it shares the same features and foundational concepts as a lot of other block-based programming. And I think you can mention this a little more, but it was an inspiration kind of for the Unruly Spots program.
Yes, and Scratch is free. You can go to their site, and there's a ton of awesome community created examples there. And members of the early Scratch team were actually on the Unruly team, so we definitely take a lot of inspiration from them as sort of the the creators truly of the first sort of block-based programming platform. And then that brings us to tip number 3, combining active learning and play. So how have you seen this increase engagement with your students and their students?
Yeah, so I think it's good to define like what active learning really allows us to do. So it allows us to kind of stimulate their attention, our students' attention. It can give opportunities for frequent feedback. Also, participation and discussion are at high levels, and they're able to think computationally and critically when they're using this type of platform. So like the Unruly platform, and using block-based programming. When in a passive learning, so to contrast that, in a passive learning is when information is just presented to your learners. The teacher really has all the control, and it allows you maybe to organize your presentation, but to really get that conceptual learning, using a type of active learning style is helpful. And so it increases engagement. You can have that student-led opportunity, but when teaching CS specifically, it allows them to take the skill of coding and then translate it to possibly another platform. So they're not just being able to apply it to the Unruly platform, but they're able to take their knowledge and their knowledge of other core content and apply them to different settings. So they'll be able to understand place value, not just in a coding environment, but when they actually use place value, maybe in their daily lives.
Yeah, I think that's a really important point. Not all of our students are going to grow up and become programmers, and that's okay. That's not what we're trying to do. Block-based coding is just the introduction to, problem solving and computational thinking and all these other skills that apply, no matter what career path your students take. So I think that's a great point. And I wanted to also point out there's sort of two different active learning definitions. We have the active as in, the student is leading their learning, but then also the physical activity. And I think that piece we were talking earlier is really important too.
Yeah, I think that's what I love about the Unruly Spots is that it engages them in a playful, actually active environment. When I think of the active learning, I'm always thinking of the cognition piece. But this platform is a bit different, as I mentioned earlier. It's that social active play piece, while also promoting this active cognition piece. And I think that's what I enjoy, which differentiates and sets this platform apart than some of the others that I've used.
So we'll go through a quick example. So this is just a quick fitness challenge, which we did with our customers in the fall, where they challenged their students to create a fitness circuit. And so each week, this looks like a kind of complex piece of code, but each week they built it a little bit at a time. And so on the right-hand side, that countdown from 10, that's really just the function of the out loud countdown from 10. So 10, 9, 8, 7, 6. And that's happening at the end. You can see on the left-hand side here, that countdown from 10 is where we plug that in. And the rest of the code is really just the timer, the stopwatch. So how many push-ups can you do in 30 seconds? And it was really fun to see the students challenge themselves and push themselves to improve every week. And it was just a great way to combine that coding with physical activity, whether they were virtual or in person. We had a ton of PE teachers who were teaching virtually, which is, very challenging. And so this was a really fun way for them to be able to hop on the video and do some push-ups live with each other and incorporate some of that coding. All right, so write us in the chat, how are you incorporating play into your classes right now? And that could be physically active play or just playfulness in general and being silly together. Write us in the chat. And again, this is a recorded session, but we're there live, so we're going to reply to you where we can.
I look forward to seeing the responses.
Yeah, me too. Me too. We always get great inspiration from these webinars with people, telling us what they're already doing. So this is great. All right, so those are the 3 tips that we have for you. Cory, do you have anything else to add before we sign off here?
No, thank you for attending the session. And if you have any questions about cross-cutting CS into your curriculum and other content, please reach out, and I'm more than happy to field any questions as well.
Awesome. And we can put Cory's email in the chat there. And again, my name is Lauren from the Unruly team. So if you have any questions or want to learn more, put my email on the slide, and our website address is there as well. So now there's some time for Q&A. Excited to hear if you have any questions or if you have any tips that you want to add on to this presentation. We'd love to hear them from you. So thank you so much for joining us today. Excited to talk to everybody more, and have a great rest of your day at FETC.
Have a good one, guys.
Thank you so much, Cory, for joining us and sharing your expertise.
Yeah, it was a pleasure. Thank you for having me.